Hey everyone, and welcome back to The Explainer. Today, we're tackling a super fascinating, totally foundational concept in programming by unpacking Skip Uni's Lecture 11. We're going to explore the abstract, kind of invisible but absolutely crucial concept of variable scope in C++. You know, if you've ever written a piece of code and wondered why the compiler suddenly threw a fit saying a variable doesn't exist, even though you literally just created it a few lines above, well, you've run headfirst into a scope issue. So today, we're going to completely demystify these boundaries using the instructor's incredibly vivid breakdowns. Okay, let's dive into this. The instructor introduces the topic with this brilliant, visceral analogy. Just think of your favorite action movie or crime drama. You've got different factions, right? And these groups have strict, designated areas or territories. If a character from one faction crosses the boundary into someone else's turf, boom, it immediately causes conflict. Total chaos ensues. Well, the instructor explains that variables in C++ operate on this exact same principle. They literally have their own turfs. If you try to pull a variable out of its designated territory and use it somewhere else, the C++ compiler is going to step right in and shut you down.
So let's formalize this a bit. What exactly is scope? Variable scope is simply the specific area within the code where a variable is recognized, alive, and usable. Much like characters on a specific turf, variables have these strict, defined boundaries that dictate their very existence. Outside of that designated area, the variable is completely invisible to the rest of the program. It's like it never existed at all. Understanding where a variable is born, where it lives, and where it dies, that's the key to writing clean, bug-free C++ code.
Section 1. Local versus global scope. Two factions. And this brilliantly illustrates how the territory system works. We really need to break our variables down into two main factions, based on the domains they control. Every single variable you create is going to fall into one of these two camps, and knowing the difference dictates how your whole program communicates. First up, we've got local variables. Think of these guys as the block-level street gangs. They're confined strictly inside curly braces, you know, those little brackets used to define functions or loops. Their influence absolutely does not extend past those walls. Now contrast that with global variables. Because they're declared outside of all functions, they have a nationwide reach. They're the universally recognized figures that everyone in the code, no matter what function they happen to be in, can see and interact with. Let's walk through a standard C++ program chronologically to see exactly where these two factions live. Imagine your code running from top to bottom. Step 1. At the very top, you've got your include statements and namespace declarations. Step 2. Right below that, but crucially before any functions actually begin, you declare an integer x. Because it's outside everything, this is a global variable. Step 3, you open your main function with a curly bracket. And step 4, inside that main function, you declare an integer y. Because y is trapped inside those brackets, it is officially a local variable. Let's highlight the sheer power of that global variable x for a second. Because you declared it at the very top, outside of any restrictive brackets, it acts as a universally accessible figure. It's got total VIP access. From the exact moment it's declared on line 2 or 3, all the way until the entire program finishes executing and shuts down, x is alive. Any function, any loop, any block of code anywhere in your file can call x, read its value, or even modify it. Let's move to and see how this builds when we contrast that nationwide reach with our local variable y. Y was declared inside the main function, right? So its entire universe is confined to the opening and closing brackets of that specific function. If you were to, say, write another function below main and try to print y, the compiler would immediately throw an error. The rest of the program is completely 100% blind to y's existence. Once the main function finishes its job and hits that closing bracket, y is destroyed. Its turf is strictly limited. Section 2. Resolving variable name clashes. So, now that we've established the territories, we've got to talk about the inevitable conflict. What happens when these designated territories overlap? Like, what happens when nationwide law clashes directly with local block rules? Imagine you've got a global variable named x sitting at the top of your program. Then, inside your main function, you declare a local variable and you also name it x. Now your program has two distinct containers with the exact same nameplate. What on earth does the compiler do when you ask it to print x? Does it just crash? Does it flip a coin? So the crucial point is how C++ prioritizes these factions. First off, and this is kind of surprising, no immediate syntax error occurs. C++ totally allows you to do this, but when you're inside that local block and you call x, the compiler evaluates the internal, local territory first. Precedence is always granted to the local variable. The local X basically violently overrides the global one for the duration of that block. The compiler essentially says, look, I see the national law, the global variable, but right here in this specific hideout, the local rules apply. So if your local X is 10 and your global X is 100, printing X inside the function will output 10. Every single time.
Section 3, the garbage value trap. This brings us to the final and honestly the most high-stakes segment of our explainer. The instructor flags this as a critical technical interview trap, and it's a bug that has literally driven programmers crazy for decades. We need to talk about default behaviors and the dreaded garbage value. To really grasp the trap, we first need to understand uninitialized variables. This happens when you declare a variable, you say, hey, C++, give me an integer named z, but you just forget to actually assign it a value, like 10 or 20, using the equal sign. You've built the container, you slapped a label on it, but you didn't put anything inside it yet. And let me tell you, in a massive program with dozens of variables, it is incredibly easy to make this mistake.
Now, what's really interesting about this slide is how the system responds to this mistake depending entirely on the variable's scope. If you forget to initialize a global variable, the system is super forgiving. It just steps in and automatically assigns it a default value of 0. No harm, no foul. But, and this is a massive but, if you do the exact same thing to a local variable, the system does not give you a safety net. It does not default to 0. Instead, it assigns a completely random garbage value. It basically just grabs whatever random leftover zeros and ones happen to be sitting in that specific memory slot at the time.
And that leads right into the instructor's intense, blinking red light warning. If you rely on uninitialized local variables, you are secretly injecting random garbage values into your program. Just imagine doing a complex mathematical calculation, but one of your base numbers is just a random chunk of memory leftovers. The craziest part? Your program will compile perfectly fine. No errors will pop up, but your outputs will be wildly, inexplicably inaccurate. It is absolutely a silent killer of logic in code.
Which leaves us with a pretty important thought to chew on. We've seen how variables rigorously control their turf, how local precedence overrides global reach, and how one simple, uninitialized local variable can silently destroy a program's accuracy. So as you go back to your own projects, ask yourself, are unpredictable garbage values secretly hiding inside your code blocks? It might just be time to audit your own coding habits, double-check those scopes, and make absolutely sure every local variable is properly initialized. Thanks for joining me on this explainer, and keep mastering those code boundaries.
Welcome to Start Studying. Don't forget to like and subscribe.